We're going to look at the multiple choice questions. Here's number 1, and the next series will all apply to this photoelectron spectrum that they've got at the top here. It's a terribly ugly spectrum, clearly hand-drawn, but we can work with it. So they want to know what element does this spectrum represent. And you remember the best thing to do right away with a PES is to start labeling the orbitals that they represent. It starts from the left. We envision the nucleus over here, and so this must be the 1s. This must be the 2s. And you notice both of those hold 2 electrons, so that's why they're the same height, more or less. This is probably the 2p, and you can see that it holds more. It looks like it holds about 6, which makes sense. And then this must be the 3s. It also holds 2 electrons like the other s ones do. And so this must be the 3p. Now you'll notice that the 3p does not hold as many electrons as the 2p, even though they can all hold 6. And so you notice it's taller than 2, but not as tall as 6. So I'm guessing it's 3. So we're going to the 3p, so row 1, 2, 3. The p area is over here, and it looks like it's a 3p3, so 1, 2, 3. Could be phosphorus. That's certainly an answer. Probably can't be aluminum because this would be a much shorter peak. It'd only be 1 hydrogen high. So I don't think it's that. Nitrogen is in the wrong period, so that can't be it. And boron is also in the wrong period, so that can't be it. So D must be the answer. While we're here, we're going to scroll up and look at question 2. Oops, that's clicking on the wrong thing there. Let's see if I can't get it. Alright, so hopefully I've got it here. And scroll up and we can look at number 2. So 2 says, which peak represents the 2s subshell? Well, if we slide it back down, you notice that the 2s we've already labeled. So the one at 6.84 megajoules is the answer. So it looks like B is going to be the correct answer here. Let's look at number 3. An electron from which peak would have the most Coulombic potential energy? You remember that Coulombic potential energy is attraction to the nucleus. And if we think about Bohr models, the ones that are closest to the nucleus have way more attraction because they have no shielding at all. The ones out here have less attraction. So we want to know the ones that are closest to the nucleus. Well, if we go back up and look at their diagram here, remember that the nucleus is over here on the right. And so the 1s is definitely going to have the strongest attraction because it's closest to the nucleus. The ones way down here are going to have much less attraction. So let's go and look at our answer set. It looks like our answer set, the one at 104 should be the answer, so A. And then lastly, number 4, how many valence electrons does this atom have? Remember, they're going to be in the outermost shell, so scroll back up, and since we have our labeling clearly still on here, the first set is in shell number 1, this is in shell number 2. Clearly the highest energy level is 3, so we have 2 electrons there because there are 2 electrons in that 3s. And remember, we decided earlier that this 3p had more than 2 but less than 6, and we thought it had 3 electrons. So that's a total of 5. Let's go down and look at our answer choices. It looks to me like the correct answer is going to be D, 5.